Okay, here's where we actually get to solving linear equations big time. We've had little pieces of it in section 2, but again, that basic principle of maintaining that balance and then reducing items until you're only left with an x on this side that equals some number. That's solving an equation. Now also at the beginning of this section 3, they do give us a recipe that's similar to this. I'm going to leave this one up. They have combined an additional step here between 4 and 5, but I'll review this as we go along. So in example 1, as we look at our equation, we don't have any fractions. But we go to step 2, get rid of grouping symbols. We have a parenthesis, so let's do that. This will be 8x minus 12 gives us and then a positive 7, and then 3x plus 5. Now we go to step 3, combine like terms. So here the 8x is okay. Here we're going to get a negative 5 and a 3x plus 5. Now this is sort of the intermediate step you want to get to, where you have a variable, a number, a variable, a number. Now you want to get all the variables on one side, all the numbers on the other. And we're going to use this transposition. So I'm going to transpose the negative 5 from this side to the other side, where it becomes a positive 5, and 5 gives me a 10. Now if you need to write that step out, do so. But as we progress, some of this can be done mentally. And as long as you're getting correct answers, that'll be good. Now we're going to transpose this to this side. That's going to be a negative 3x. That gives me my 5x. So now I'm in a position where I only have variables on one side, a number on the other. Now what I want to do here is isolate the x. And again, I want to get rid of the term or the portion of that term so that I'm left with just a plain x. So this is where we're going to divide by the numerical coefficient of x, which is 5. And again, to keep the balance, we have to do it to both sides. We end up then at x equals 2. And if you do a check on that, that does check. Okay, going on to example 2. Again, we don't have fractions yet. Get rid of grouping symbols. So this will be 16 minus 18. You really need to be careful about the signs. Equals a negative 5t. Now, again, we want to try to keep our t's positive. So I'm going to transpose this to the other side. That'll make it a positive 8t on this side, which then leaves me with a 3t. Now, here's where it gets a little tricky. Because when we divide both sides by our numerical coefficient of t, which is a 3, we end up with a fraction. And fractions are okay. And generally you just leave them as a fraction. Now as we get on to example 3, we now have some fractions. And this is perhaps the most important skill you'll need, because students often see something like this and it sort of wipes them out. But it actually is not that difficult. Watch what we're going to do. We are going to look at our fractions, our denominators, and figure out what's going to be our least common denominator. Now we have a 2 and we have a 3. If we were going to add them together, our least common denominator would be a 6. So what we do is we take that least common denominator and multiply it by each term in our equation. So we're going to multiply this by a 6, this by a 6, this by a 6, this by a 6. So we're keeping, again, our balance here. It's not going to be the same equation, but it will be an equivalent equation without fractions. So the 2 goes into there once, this becomes a 3. No canceling there. 3 goes into there once, that becomes a 2. No canceling. So now we rewrite the fraction, the equation without the fractions. So this is going to be 3x minus 6 equals 4x minus 18. We have made an equivalent equation without fractions by multiplying each term by the lowest common denominator. And now we just do our transposition. We want our x's to be positive. Transpose the 3x, that becomes a negative 3x, x. Transpose this, that becomes a positive 18 minus 6 gives us a 12. And there is our solution. Wow. Just using that little technique of getting rid of fractions by multiplying every term by the least common denominator. And in example 4, we see another kind of fraction. But again, the same technique. What would be your least common denominator? 3. So actually, this is one term because of this grouping symbol, the division bar. So we're going to multiply that one term by a 3. Here there are 2 terms. Multiply those by a 3. Here the 3's cancel out. And now we're going to multiply through to get rid of our grouping symbol. 2a plus 6 equals 18a plus 6. We want our a's to be positive. So I'm going to transpose this to the other side by subtracting 2. This becomes 16a. I'm going to subtract 6. Oh, wait a minute, I'm getting a 0. But let's let it be known that is absolutely good. Now we're going to divide both sides by 16 to isolate the a. And as we had earlier, any number, anytime 0 is divided by any number that's not a 0, the answer is 0. So here we have a equals 0. And let's just check it out. And we'll get rid of this up here too. So if a is 0, let's use red here. 0 plus 3 is 3. 2 times 3 is 6. 6 divided by 3 is 2. If a is 0, 6 times 0 is 0 equals 2. And the check is correct. 0 is a good answer. Now there are some equations where other things happen, and we'll be going over that as we continue. Now another type of fractions that we're going to have are decimal fractions. And if it's very simple, probably you wouldn't do this, but in something like this, you want to get rid of those decimals. And there are 3 terms. So you're going to multiply each term by something that would get rid of the decimals. Well, if it were just 1 decimal place, you would multiply by 10, move the decimal place over 1. But if it's 2 decimal places, you're going to multiply every term, in a sense, I can do it this way too, by 100. That then just moves the decimal place over, and you get rid of all your decimals. And then you rewrite it. This will be 25x. This is now a 10x minus 30 equals 110. Notice, without the decimals, a lot easier. Now, group-like terms, 35x. I'm going to transpose that to the other side. This gives me 140. I'm going to divide both sides by the numerical coefficient of x. X equals 4. And it checks out. Now I've left this up here, so again it's showing you what we're doing. We are adding, subtracting, multiplying, dividing, so that we keep a balance, so that eventually we get a letter equals a number. This is your solution. And we got to it through the steps of solving an equation. Now, this is our next one. No fractions. But again, we have to get rid of parentheses, step 2. So let's do that carefully. Negative 2 times x, negative 2x. Negative times a negative gives me a positive 10, plus 10. Negative 3 times x, a negative 3x. Negative 3 times a positive 3, a negative 9, plus x. So now we're ready to do step 3, collect like terms. So this is a negative 2x plus 20 equals a negative 2x plus 9. Uh-oh. Now, notice it started off looking like an equation, had the equal signs. But notice, and I'm going to go back to an earlier system because I want you to see this clearly. To get the x's, if I subtract or add 2x to this side, and I add 2x to this side, my x's are going to cancel out completely, and I'm left with 20 equals 9. Now, does 20 equal 9? And the answer is no. This is a not true statement. Whenever you do an equation and following the steps that we've suggested, and you end up with a not true statement, the answer is there is no solution. You have an equation that's not really an equation. But again, you don't know that because you had to follow all the steps and you ended up with something. Now, there's another one that we're going to probably be doing, where you end up with 0 equals, let's say, 0. Is that a true statement? Yeah, there's no more x's or letters, but you end up with a true statement. That is a case in which the equations are actually the same, and you have like a 2x plus 2 equals 2x plus 2. So if you subtracted 2x, subtracted 2, you'd end up with 0 equals 0. So now, whatever number you put for x on this side, and you put it on that side, that's a solution. So this is a case where the answer would be all real numbers. I think they're probably going to give us an example of this shortly. Yes, example 7, we clear parentheses. And notice, it's what we said. If we subtracted a 3x from here and added 12, we'd have 0 equals 0. So these equations are the same. That is, the expression on one side is the same as the expression on the other. So whatever value you put here would make this a true statement. So here's an example. Now notice it didn't look like the same equation at first because you had to distribute that first. So here the answer is all real numbers, and they often just use the capital R to indicate that.